Welcome to this video on one-step multiplication and division equations. Today we're going to review how to solve addition equations. We're also going to get into multiplication and division equations. So it starts here with page 120, and we're looking at how do we write expressions for the number 1. Last time we looked at the number 0, and now we're looking at 1. So we could do a 1 times 1. We could do a 1 plus 0. Sorry, that looks a little bit like a multiplication, I promise. It's supposed to be plus. And then 2 divided by 2, and then 5 minus 4. And then this 2 divided by 2 kind of set us on this path of a 2 over 2. If you remember with fractions, it's anytime you have a number over the same number, it equals 1. Okay, the reason is it's just like division. This fraction bar acts like a division sign. So 2 divided by 2 would be 1, 3 divided by 3 would be 1, 4 divided by 5 divided by 5, and so on. We could go to any number. Any number over itself equals 1. Okay? Now we also kind of jumped ahead to what we're going to be doing tomorrow, and that is fractions. If I have 1/3 and I multiply it by 3 over 1, that equals 1. Or 2/5 multiplied by 5 over 2, that equals 1 as well. We call these the reciprocal or multiplicative inverse. Sometimes I call them the flip, because what you do is you take the number and you flip it. All right? But again, we're going to worry about fractions tomorrow, but it kind of applies here because we're looking at the number 1. Okay? Now, we're going to practice adding equations. Remember, first step is to draw this line down. Okay? These are equations. We want to keep them balanced. Okay? And then the next step is to look at the variable, find it, and ask what's happening to it. Okay? In this case, x is being added by 9. Well, we don't want x plus 9. We want x. So we need to strip away or get rid of anything that's attached itself to x. So that's why I always have you ask, what's happening to the variable? Well, it's being added. So we want to undo that by the inverse operation, which is subtraction. So undo 9 by subtracting 9. And when we do that, we're left with x. So these cancel out, and the only thing that's left on this side is x. So I'm going to put x down here. And then I need to do 12 minus 9 to get my answer. 12 minus 9 is 3. So x equals 3 is my answer. And I've got to put the equal sign in here. Okay, if I don't, it's not a correct answer. It's not an answer to this equation. And then again, I could check by putting 3 in for x and ask, does 3 plus 9 give me 12? And it does, so I know I have the right answer. So I can circle it with confidence. And then on number 2, what's happening to my variable? It's being subtracted. So again, we want to undo what's happening to the variable. So to undo that, we got to do the opposite of subtraction, which is addition. And we're going to add 1, not to just this side, but to this side as well. So when I do that, these go away because I'm undoing that subtraction. Okay, so I'm left with s. And then 10 plus 1 is my answer, which gives me my answer. It's not my answer. It gives me my answer, which is 11. And then I can check 11 minus 1 would give me 10. So I can circle that with confidence. So just an opportunity to do a little bit more practice here. Again, ask what's happening to the variable, do the opposite of that to both sides, and then get your variable by itself and then find out what that variable would equal. Okay? All right, we're going to move on next to multiplication and division. Okay, on page 127, we see this example problem, 4r equals 32. Now, it's really important that you remember when 4 is next to a variable, it means to multiply. So 4r equals 32. So since r is being multiplied, eventually what they're going to do is divide both sides by 4. Now, they do a few extra steps here to kind of explain why this works. Okay, but the basic idea is for r is being multiplied by 4, we want to undo that, just like we did with addition and subtraction. And to undo multiplication, we divide. Now they use this fraction bar, which is the same thing as a division bar. So 4 divided by 4 gives me our 1, r. And then 4 times 8, so they decomposed this 32 so that it had 4 times 8. And these 4's cancel out. So we're left with 1r equals 1/8, which r equals 8. Okay? So let's look at that a little bit different. All right? So before that, our solution is r equals 8. And are there any other solutions to this equation? No, only 8 is the solution. It's the only thing that will make it true. All right? Now let's look at this. 8a equals 72. What's happening to our variable? Again, that's the first question we ask. What's happening to our variable? It's being multiplied, so we want to do the opposite. And like we said over here, the opposite of the operation multiplication is division. Okay? So I'm going to divide both sides by 8. And then what's left over here, 8 divided by 8 would be a 1. 1a is the same as a. Kind of looks like a 9, but it is an a, I promise. Okay, then 72 divided by 8 is 9. So a equals 9. And again, how can I check? Put 9 in for a. 8 times 9 is in fact 72. So I can circle with confidence, I got it right. Okay, b, 11 times t. So t is being multiplied by 11, so we want to divide by 11. So both sides get divided by 11. What's left on this side? Just t, because these cancel out. All right? And then 132 divided by 11 gives me 12. And then I can check, does 12 times 11 give me 132? And I think it does. So again, I can circle with confidence. All right? Now, over here, we see a different situation. It says 5 equals p over 7. Now, that kind of looks like a fraction. But really, p over 7 is the same thing as p divided by 7. So that bar there means division. So when you have a number next to a variable, like on the previous page, it means multiplication. When you have a variable over a number, it means division. That variable is being divided by 7. So the opposite of dividing by 7 is multiplying by 7. So I multiply each side by 7. That cancels out the 7s. I'm left with p, and then 7 times 5 gives me 35. So it says, Diego says to solve 5 equals p over 7, he would divide by 7. The value of p makes the equation, the value of p that makes the equation true is 5 over 7. But Benita disagrees and says they should divide by 1/7, and the solution is 35. Who's correct? Okay, well, it just sounds complicated, but basically, he says it's this. Okay, I'm plugging this in for p. 5/7 over 7, does that really give us 5? Or does 35 over 7 give us 5? Well, it's obvious to see. 35 divided by 7 is going to give us 5. So this is not right, but Benita is right. And then how can we check? Well, what do we do here? We plug in the number for the variable. We call it substitution. And when we substitute, we can see if it's a true statement or not. And if it is, we know we have the right solution. Okay? So here's a worksheet giving you a chance to practice. Remember, when the variable is next to a number, it means multiplication. When the variable is over a number, like in this case, it means division. Sometimes they'll use a division sign like here, but sometimes they'll write it like this. Okay, don't freak out. It is not a fraction. Just pretend and treat it like it's division. So again, 4 times w, what's happening to our w? It's being multiplied, so we want to undo that multiplication by dividing by 4. 8 divided by 4 is 2. So 2 is w, or w equals 2. Okay, over here, y is being divided by 10, so I want to multiply by 10. So what happens over here? I'm left with y. 8 times 10 gives me 80. All right? And so here's the rest of your worksheet. Go ahead and work on it like that. Remember what's happening to the variable, and then undo that by doing that operation to both sides, and then get your variable by itself. And then that'll give you your answer. All right, thank you for watching.